Hello students, this is lecture 1 of MTH 201 Multivariable Calculus. We are going to begin by introducing geometry of R3. So what is R3? R3 is a collection of points written as an ordered triple of the type x, y, z, where x, y and z are real numbers, and they are written within round brackets, and ordering is important. Okay, so for a given point P, A1, A2, A3, A1 is known as the x coordinate or the first coordinate of the point P. A2 is known as the y coordinate or the second coordinate of the point P, and A3 is known as the z coordinate or the third coordinate of P. Okay, so for every given point you have coordinates x coordinate, y coordinate, z coordinate, and they are determined by the respective entries in the representation of the point. In R3 you can add 2 points. So if you take 2 points a1, a2, a3 and b1, b2, b3, they can be added in this fashion. So you add term wise, okay? So or coordinate wise. So a1 plus b1, a2 plus b2, a3 plus b3. You can also multiply a point with a scalar. Scalar in this case is real number. So if alpha is a real number, alpha times the point a1, a2, a3 is nothing but alpha a1, alpha a2, alpha a3. So this alpha scales each component of or each coordinate of the point by this scalar or real number alpha. Okay. So in R2, the third component is dropped. Okay, so this third entry, which is Z, is dropped. And R2 is the collection of points written as an ordered tuple x, y in round brackets. So you will see later that there is also R to the n, where n is the superscript for any natural number n. So how many ever, the value of n will tell you how many coordinates are there. Okay, so when this n is 3 or when this superscript is 3, then you have 3 coordinates. If the superscript is 2, you have 2 coordinates, right? Okay. So in R3, this is how you represent R3 geometrically. So you have these three axes, x-axis, y-axis and z-axis. Okay. So this x-axis, the bold x-axis here that you see is the positive x-axis. And on the back side, this is the negative x-axis. Now this top is the positive y-axis and the bottom is the negative y-axis. This front one is the positive z-axis and this is the negative z-axis. But in the entire axis is called x-axis, this is called y-axis and this is called z-axis. These are called coordinate axes of R3. Then there are what are called coordinate planes. So if you look at this blue plane, okay, so what is this blue plane? This blue plane contains this x-axis and y-axis, right? And z-axis is actually perpendicular to this blue axis. Okay. So now the z-axis is perpendicular to the blue axis. So this blue plane, okay, and this blue plane is called xy plane because it is containing x and y axis. Similarly, this red or orange plane contains x-axis and z-axis, and it's called xz plane. And this green plane that you see is containing the z-axis and the y-axis, and it's called yz plane. So if you take any point on the blue plane, which is in the xy, which is called the xy plane, any point on this plane is of the form x comma y comma 0, because there is no z coordinate. Okay, z coordinate, I mean there's no z, there's no value in z, z is just 0, because you're not you have not moved in z direction at all. So by the way, this point that you see here is called origin, and it is 0 comma 0 comma 0. Okay, so all the three coordinates are 0 for this given. Okay. And similarly, if you are on the red plane, then any point is of the form x comma 0 comma z, because you have not moved in the y direction at all. And similarly, you have this, the point on green plane looks like this. So let us understand this part more by looking at pictorial representation of a point. So if you take any point P, which is x comma y comma z in R3, let us try to understand what these coordinates x, y, z are. Okay. So what you do is, you look at this point which is in R3, and you drop a perpendicular from this point to YZ plane. Okay, so drop a perpendicular from P to YZ plane. So this perpendicular is actually this red line, right? That is the perpendicular. Okay, so you drop a perpendicular from the point P to YZ. So this is the red line. Okay, now you look at this line here on the x-axis. So you can already see that there is a cuboid that is drawn here in R3, and I am looking at this side which is perpendicular dropped on YZ from the point P, and you look at the other side of the cuboid. Okay, now you know that it's a cuboid, so the length of this is same as the length of this. So whatever is this length, this is x, the x coordinate of P. Okay, so this is the x. Now what are the coordinates of this point P sub x? They are nothing but x comma 0 comma 0, because you are on the x-axis. There is no component, there is no coordinate of y and z. Similarly, you drop a perpendicular from P to xz plane. Okay, when you drop this perpendicular, this is this green line that you see. You look at the side which is now on this back side on the y-axis. Because it's a cuboid, the length of this is same as the length of this, and this is basically the second coordinate of this point, which is y. Similarly, you drop a perpendicular from the point P to the xy plane, which is nothing but this blue line. Now you look at the corresponding side on the cuboid on the z-axis, which is this, and this distance from the origin is called z. Okay, so that is how your coordinates of a point are described. Okay, now let us talk about geometry R3 using vectors. Okay, so far we have talked about points in R3. So what is a vector? A vector is a directed line segment beginning at the origin. So remember the origin 0, 0, 0. That is, a vector is a line segment with specified magnitude and direction with origin as its initial point. Okay. So what you do is you decide a specific length and a direction, and you draw an arrow which is directed like this. So here in this picture we have drawn several directions. So this is one, this is another, this is third, and there is a specified length. We'll come to the concept of length or magnitude in a while. But at the moment, you can think of taking some particular length vector and placing it so that it starts at the origin. Okay. So there are infinitely many such vectors, right? So if you take any point a1, a2, a3 in R3, we can associate a vector whose initial point is origin and terminal point is a1, a2, a3. So let me explain what I am trying to say here. Initial point meaning where it starts, and terminal point is where this head ends, where it ends. Okay. So you can start from 0, 0, 0 to a1, a2, a3. Okay, that is so for any given point in R3, we can associate a vector which starts at 0, 0, 0 and ends at a1, a2, a3. Now, such a vector is denoted as a1, a2, a3 in triangular brackets, where a1, a2, a3 are called the components of the vector. So remember, for a point we were using round brackets. For a vector we will use triangular brackets, and for a point these entries were called coordinates. For a vector we will call them components. Okay. So that is something that you have to remember. So I'm going to use this notation throughout this course. For a point you will use round brackets, and for a vector you will use triangular brackets. Okay. Now two vectors a1, a2, a3 and b1, b2, b3 are equal if and only if they are equal component wise. Okay. So a1 is equal to b1, a2 is equal to b2 and a3 is equal to b3.